Hello, today we'll be working on rules, tables, and graphs. Today you'll be trying to understand what a rule actually means and how it can allow us to plot points and ultimately draw a graph. So what we want to take a look at before we even start this topic is to understand very quickly what we did when we did this chapter. Coming up with the coordinates, we were able to come to an understanding, hopefully, that these two numbers express coordinates on the x-plane and the the x-axis and the y-axis. We know that the first number is the x-coordinate or the horizontal coordinate here, and the second number is the y-coordinate, or should I say the vertical coordinate, which then allows us to then plot this point where it's 2 across and 3 above. So that gives us that understanding. When we work on our topic today, we actually are not given an xy coordinate. We're given a rule, and this is the rule: y equals 2x minus 1. Now, the key is to understand this y and x is the same thing as we used when we had those coordinates, with the first number being the x-axis, which is of course the x-coordinate, which is how far across horizontally the coordinate goes, and the y here, which tells us the vertical, how far it goes vertically, upwards or downwards. What we need to do here is, when we have this rule, we need to come up with a whole series of plots, so coordinates. So we want xy coordinates. You can see here I can come up with a table, and that table can have 5 different coordinates, which will then give me a pattern that will allow me to see, oh yeah, that's the graph I'm going to draw. Now, what numbers should be in this table? Well, we'll suggest that we'll put 0 in the middle, and we'll create a graph where if they don't specify what the x coordinates can be, you can simply have a 0 in the middle, go up by 1, so you have 1 and 2, and then go down by 1 over here, and you've got -1 and -2. So you've set these 5 values, x values, you've set them. It's not a value. These are not answers of any kind. You're setting that these are going to be the x values you're going to investigate, and the y values will be based on what this rule tells me. So for example, let's look at this one first. We want to determine what that y value is. Now, well, you have an x value. The x value is 0. Okay, so all you have to do is write the rule down. Y is equal to 2x minus 1. Okay, that's the rule that we want to follow. We want to substitute. Okay, so we want to substitute, and we want to substitute what we know. And what we know is x is equal to 0. So instead of, now we have in our next line 2 times 0, right? Because x has been replaced with 0. We've said that this x value will be 0. And so now we simply just work what that out is, and that is 2 times 0, which is 0, minus 1, which means that this is -1. So the y coordinate, the corresponding y coordinate to this 0 x coordinate, is -1. Okay, and we can just do this for every single value. And in fact, we don't actually need to do this working out every single time. What we need to do is just simply understand what we're trying to accomplish here. So this time we still use this rule. Remember, this is the rule that we're using, but now we're going to replace 2. So this one, we have 2x minus 1. This time we're replacing x with 1. Okay, instead of 0, we want the x value to be 1. So this is 2 times 1 minus 1, which is equal to 2 minus 1, which is equal to 1. So this value here is 1. Okay, so this time we've substituted the x value with 1. And we do this so on and so forth, and suddenly, shouldn't say suddenly, but hopefully you will eventually see a pattern. Let's do the third one, just one more step. So this one here. Okay, here we're going to have y is equal to 2x minus 1, saying the rule stays the same. We substitute the number x. This time our x is 2. It's 2 times 2 minus 1, which is equal to 3. Okay, so this is 3. Now, what I hope you notice is that what's actually happening every single time we go up one value. So remember, the x value is going up by 1 every time, right? That's what we've set it to be, okay? But what's happening down here with these values, -1 to 1, 1 to 3? Well, there's a pattern that's actually happening, and the pattern is that we're plussing 2 every time. Okay, now if we follow this pattern, it allows us to go backwards too. So if we're plussing 2 here to get these values, we simply had to do the opposite, going backwards. So we minus 2 here, we're going to get -3. Okay, and if we go backwards again, this will be -5, and it will follow that same rule where we plus 2 every time. Now, for those of you who are sort of starting to understand this, you might start to see some patterns. And I want to show you those patterns, but you may not necessarily understand it to begin with, and that's okay, but just want you to see them. What I want you to see is that these +2 values are not accidental, okay? They're going up by 2 every time x goes up by 1 because this number is found in front of the x. This is what we will later call the gradient, but right now you don't need to know that fully. That tells you how fast this number is going up as x is going up by 1. So every time x goes up by 1, this number goes up by whatever that number is. Here it's 2, so it's going up by 2. If it was -2, it would be going down by 2. Okay. The second thing I want you to notice is what happens when x is equal to 0. When x is equal to 0, we have -1 or -1. And you might be like, okay, so, well, think about it. When we did this, 2 times 0 will just equal to 0, which actually cancels out this entire thing. So the only thing that's left is this -1. So this number actually is existing all along. We just, it was always in the rule. And in fact, if you see here, it was always in the rule. This -1 is what we eventually called the y-intercept, but we'll talk about that a little bit later. But that's how the -1 comes about. Right now, you don't fully need to know about the gradient and the y-intercept, but you do need to make sure you're able to substitute these values, because then you'll be able to come up with your graph. I want you to see that these are 5 coordinates. Okay, they're not written the way that we were writing them before, but they're 5 coordinates. Here are the coordinates. Okay, we've got -2, 5 as one coordinate. We have -1 through -3, which is the other coordinate, and then we can keep going, and we can create all the coordinates, or should I say come up with all the coordinates that we had. And these are the values. You can see here's the x value, here's the y values, here are the x, y values. And we can plot this onto this graph right here, which is what we're going to do. Okay, so -2, 5, we've got -2, down here 5, -5, oh sorry, 5, so it's positive. So it's up here. Now, we don't have a 5 here, but we're just going to assume that extra grid is going to be 5. -2, 5, -1, oh sorry, -2, -5. I did get that wrong. -2, -5, so that would be down here. -1, -3 would be over here. -1, 0, -1 would be here. 1, 1 will be here. And finally, 2, 3 will be here. And I hope you've noticed this creates a straight line if I've done everything correctly. And you can do that as well. That's our straight line. So this is what we call a linear graph because it creates a line. This sort of equation, that y equals 2x minus 1, is what we call a linear equation because it will always create a linear graph. Now, you will have to be able to do that. And next on, we're going to be able to do this question and you'll be able to be ready for the chapter. Decide if the points 1, 3 and -2, 4 lie on the graph of y equals 3x. Okay, so here's the rule. Y equals 3x. The points 1, 3 and -2, 4 can only be on this graph if they satisfy that rule. How do we check that? Well, remember the first number is always the x, second number is always the y, just like this one. First number is always the x, second number is always the y, and we just do a quick check. Okay, so let's check 1, 3 first. That's 1, 3. So for 1, 3, okay, let's think about this. So we're going to replace, this is our rule. We're going to replace the y value with the x value. Okay, so sorry, the y value with the y value here, and the x value with the x value here. Okay, we'll do that. So that becomes, y here is 3, x here is 1, so it's 3 times 1. And do they match? They do match, so great. That coordinate lies on this graph, okay, because then the numbers work. 3 equals 3. Try the second one. So the second one is -2, -4. Okay, let's try it. Y is equal to 3x. Let's replace y and x with the values that we have here. Y is equal to -4. X is equals to -2. So this becomes -4 equals -6, which doesn't. So no, this is not on the point. Okay, so not on the graph. So this, yes, lies on the graph. This, no, doesn't lie on the graph. Okay, hopefully that makes sense, that you can use these two questions and you should be able to confidently complete